And welcome to day 7. One full week of Advent of Code in the books. Pretty exciting. I'm thinking about not streaming this part of the setup in the future, just because it takes the time, and I don't know, maybe folks find it interesting, but I've been doing the same thing for a couple days now. Maybe I'll stream it if I do something new. Especially waiting for the file kind of listing to refresh. Still can't find a way to force that. I thought reload from disk would do the trick, but I think it's actually just reloading this file from disk. Though, if I reload the folder from disk, oh, okay. Learning something new every day. That's what it's all about. Here we are, input, day 7. Let's run it, get that first output, and clean this up a little bit. Get the start watch loaded, and we go over to the calendar. Look at this nice pattern we're getting in here. We're getting some green dots showing up now. I'm really curious what this is going to be like in the end. I didn't make it to the end last year, so pretty excited for that. With that said, let's get underway. Let's hit that start button and go into problem 7. Land, next flight. We've already had some time to grab some food. Ooh, fancy. Flights are currently delayed due to baggage processing. Alright, so we're baggage processing. Many rules. Okay, so we got baggage processing rules. Have to be color coded, sure. And quantities. What? The bags have to contain quantities of other bags? Nobody responsible can tell how long they would take to enforce. Light red bags contain 1 bright white bag, 2 muted yellow bags. Man, they're really going with lots of colors. You could just use hex codes, goodness. Okay, so it's just rules about what is inside bags of certain colors. These rules specify the required contents for 9 bag types. Okay, there we go. In this example, every faded blue bag is empty. It is? Oh, faded blue bags contain no other bags. Vibrant plum bags contain 5 faded blue bags and 6 dotted black bags. 11 bags. Okay. You have a shiny gold bag. That's this one. These 3 bags. 1 dark olive, 2 vibrant plum. If you wanted to carry it in at least 1 other bag, how many different bag colors would be valid for the outermost bag? Whoa. Whoa. Okay, this is not where I thought this was going. So shiny gold is here, and I guess there's shiny gold bag singular. So these 2 can contain shiny gold bags, and the others contain it. Okay, I'm not sure yet on a solution format. Okay. In the above rules, the following options would be available to you. A bright white bag, which can hold the bag directly, and muted. Yep, those are the 2 we found, these 2 bags. A dark orange bag, which would hold the bright white and yellow muted bags. Ooh, it's kind of like a tree? A little bit tree-like, but organizing this data into a tree is going to be a bit of a pain. And the number of bag colors that can eventually contain at least 1 shiny gold bag is 4. How many bag colors can contain at least 1 shiny gold bag? The list of rules is quite long. Make sure you get all of it. Yeah, we'll do, good sirs. Alright, so that took me 2+ minutes. Good to know how long it's taken me to read these puzzles. So we got 500 lines of rules. It looks like the rules are 1 to a line. They always end in a period, and the big idea here is that the first 3 words are always describing the bag, the first 2 being the color. There's always like a tint and a name, but it doesn't matter, it's just 1 string. We don't really care about the word bag or bags because we're going to drop that. So if we take the first 3 words, and they always say contain and a number. Do we care about the number though? We don't, at least not at this stage. Something tells me that's going to come up. They didn't put numbers in this for nothing. How to construct. Okay, so at a high level, we don't have to make the tree. We're not being forced to. It becomes a bit of a recursive search, right? If I see once I build out the structure of kind of the rules of like the what bag contains what, and then I'm thinking of a map of strings to lists of strings right now, or a map of lists string to set of strings, since order doesn't matter. And let's see, we have a set of strings, and then when we kind of come across the bag type, right? So we start by looking for the shiny gold bag inside of the keys. The directionality is not great. What we want is for every kind of bag to note what is the outer containing bag. So like with this one, right? Because I want to look up by the inner bag. So I would say like I would map bright white to light red. I would also map muted yellow also to light red. And so bright white is going to eventually map to all sorts of outer bags. So it's going to be a mapping of the inner bag to outer bag set. Okay, let's start sketching this out. Each line, let's see these rules. Let's grab some. Actually, let's stick with the suggested little use case here. Wow, I can't believe they actually made the file be what's the word? They actually made the file just words. That's really funny. Day 7 input small.txt or sample. I never know what I want to call it. So we have this. Oh, I did want to check all the way to the bottom. Oh man, command down doesn't work. All right, let's get to the bottom here. I do want that extra new line. And then, okay, so if we have each of this and we do small, for every line, what we're going to do is we're going to parse out and return a, let's return a bunch of pairs. No, I'll read it later. I'll just do the individual thing. The first thing that we return is these two words, and then we'll take care of the rest later. So I'm thinking, let me just take a peek at the longer inputs just to get something longer to reference here. We split by commas, then grab the first two words of the first element, then grab the last kind of, third to the end and second to the end of everything else, and that's the inside. So let's take a look here. I'm going to copy one of these lines because I'm tired of jumping back and forth. All right, let's do it. So we got a line. We do line dot split by comma, and so then we can say I'm just going to say line outer equals line at the 0th and the 1st. So that's everything up to 9, including the second element. Oh, no. Everything up to the second element of the first element. Let's be clear here. And then for everything, for element in line of everything else, so 1 through the end. Oh, but we still care about the first element, actually, because the first element has this one. We're going to take element, which is going to be a string without the comma. It'll look like that. Split by space, so that's a standard split, and grab these two buddies. So that's -3 to -1. Man, this is the worst. 0, 1, 2, 3, 4, 5 at -3 to -1. I'm thinking, if I'm right, it should get a 34. 34, okay, good. Quick little test here. So we're going to grab those two words as one string. That's good. And that's inner. Inner dot add. I'll just return the list, I guess. Yeah, we'll just return the list. Append. So we'll let's call it output. So output is this. Come on. Output is that. We're going to wrap this in another list. So then we can append to it, and we'll return output. And so for each of these, we're going to get the color rules or something. Let's just return those color rules and print it out. What did I do wrong? Indentation. Inconsistent use of tabs and spaces. Really? You don't say. Why would that be? Okay. Just redo that line, I guess. Okay, sure. Li, muted. Okay, so I screwed up the first thing. Oh, because the first element is this. I had the same problem down here, right? Yeah. I need to split and then get the first two. Yeah. So dot split. This is getting messy. There we go. Light. Now I'm getting light, comma red. Light red, bright white, muted yellow. Let me just copy that so I have the exact example for that first line. Oops. Light red, bright white. Oh, because they're already a string. Okay, okay. So this is a list. This is a mess. That's what this is. Let me break after the first one, just for a clean version in here. Why is this showing everything? What am I doing wrong here? Light red, bright white, dark orange. And look at this, dark orange is here? What is going on? Light red and bright white are being wrapped in a double list. And then bright white is showing up again. Oh, because each line is a new thing. But that still doesn't answer why. Each line should have had just, I just want light red, bright white, dark orange. Apparently, that's too much to ask. What am I doing wrong here? So line, okay, let's start printing out some stuff here. Print output, man, blew it. Okay, so it's doing all of these. Oh, it's because I'm not breaking after the, no. Yeah, it's because I'm using getFile, so it's doing all the lines. And this is doing a double list. Oh, and then when I append to it, it's a mess. Okay, okay. So the first thing I need to do is fix the fact that, and then this isn't doing me any favors actually. So I need to join these, right? I'm gonna go handy, a little helpful function. We might move this to util someday, but for now, can I just call it join? All right, I can just call it join. Great. I just like to have, oh, we can have the char kind of optional little character in here. Character dot join on string, and we're going to return that. And I'm going to call join on this list. Oh, and not string, it should be the list. Yeah, I'll fix that in a sec. Join. Okay. It should be like sequence. Right? It should be some iterable. Okay, so that fixes light red. It fixes the beginning of each one. Light red, bright white, muted yellow. And so I need to fix each of these. All right, we're getting there. So we split, we get these two words, and then this whole thing needs to be in one of my little fancy joins. I know it's like only a little different than just directly calling it, but it's nice. I think that's as good as it's gonna get. All right, so then we can say, I'm going to put print color rules here because I'm going to need that later. Probably keep an eye on it as we go through. So we're going to say for line in color rules. So for each rule in color rules, we need to make a map that goes. So let's call this rule map. We're going to the dictionary that rule map at rule. Just do R. Well, let's get them all out one by one. Rule at 0, right? That's the outer. And then inner is rule from 1 to the end. And so then we want to go through each of the inners for inner, for bag and inner, for inner bag, let's call it. Inner bag and inner, we're going to put rule map at inner bag to be outer. So each of the inner bags will be mapped to its corresponding outer value. So let's see what that looks like after just one break. After just one line of rules, I want to see it. So we'll just print rule map and return. Good. So bright white got mapped to, yep, light red, and then muted yellow also gets mapped to light red. Good. So let's get rid of that. Oops. Run it again. Bright white now has lots of other mappings, which is good. So now we'll say we have gold, shiny gold. So now we're looking for, okay, so we made this thing. We don't have to return it, we can just use it. Really a recursive call. So let's actually make a little thing. So this is just to build the map, and then we'll say how do we know when we're done? When we run out of, ooh, that is a weird, what is the base case? When we get to a, because we're going to look up by key, we're going to look at all the values for each of the values, look up all the other keys, and at some point we won't be able to find any, and we'll return none, something like that. Okay, let's just return rule map then. Well, I can just call, I'll just call the recursive function from here. So we'll call look up rule, and we'll pass in the rule map. Not loving that. And we should return, what are we returning? The number. So let's make this rule, lookup rule function. All right. Map, rule map, rmap. And we'll say, and what are we looking up exactly? Yes. All right. Shiny gold is my thing. So we're going to say this is what we're looking for. Bag, lookup. It really should be lookup rule or something. I mean, lookup bag. Find refactor, lookup bag. Do the refactor. And we're going to look up in rmap at bag all of the possible values. So for all of the strings for bag in, not bag, for color in this bag, we're going to call lookup bag on that color, and we'll keep passing it into rmap. Something like that. Rule map, it will look it up. We'll return it. And so each time we find one of these things, so when we get to the end, right, when if bag not in rmap, return 1. Okay, And then we're going to sum up all the return values. Yes, yes, yes. So total equals 0. And then we're going to do the lookup bag. We'll return the total. Yeah, total plus equals each of these calls. Return total. So we either return 1 for the base case, and then as they come together, then they'll have a number, and that'll go up to the top, and we'll get a number, and I'll run it, and it got 12, and I hope that means something. Ah, recursion is the worst. No. Okay. Oh, it's because I did small input. Whew. So was the answer 12? Return to day 7, because like, okay, so it's 4. It's good to know. Didn't quite get that. Now we got to trace it. So if bag not in RMAP, return 1. No, no, no. If bag not in RMAP, return 0. But if it is in RMAP, then return 1? But then for each one, oh, we want to return the count. Yes, 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 yes. We'll make the calls and then return the number of things that came back. So at the base most layer, no, if it's not in RMAP, of course, we return nothing. But if it is in RMAP, we need to get that color and return the number of the size of RMAP, right? Like these are lists of strings, sort of. Oh no, it's one directional. Remember, it's the inner mapping to its corresponding outer. So every single, right, every inner only has one outer? That's not right. Oh, I screwed this up. Every single inner, this is a, it's the, if it's there, then do the thing. If it's not, then, okay, it's a upsert, but with a list, so it should be outer wrapped into a array or a list, and we need to do rule map.get inner bag. If it's not there, we return an empty list, and we say rule bag inner this is that, and then we append outer to that rule map, and then we'll have a list. Yes, okay. And then we can say, once we have that list, then for every single one, we'll do the lookup, and then, I mean, at some point it's not going to be in there. I think we still need to return 1. Yeah, okay. Yeah, that makes sense, because when it gets to the end, that's where the count accumulates from. 82, okay, let's try that. Ooh, brutal. Not great. Because we had 4. I don't know if you saw that, like with small, we got the 4, so we're on the right track. But somehow the edge case killed me. So each of these have some kind of, whatever it corresponds to directly. Yes? Yeah, so the inner bag corresponds to the outer bag. The outer bag then needs to be the new inner bag somewhere, right? So that's kind of what we're trying to do here. We're saying shiny gold needs to be the inner bag somewhere. And so we say, is shiny gold, because if it's not in the map at all, returning 1 doesn't make sense. So from that perspective, this is not a great base case. But it's like, if it is, shouldn't the length of each one. Okay, what if we did this? Return 0, and we say the total equals the length of our map at bag. So it's like the size of that list is the total. And then when you go down a level and you go to each one and we say, what's the size of those? The size of that is a new total. So if we return that, it's 183. I gotta check the small though, like it would be irresponsible not to. See, now I got 6. It's absurd. How is this counting wrong? All right, we gotta look at one by one. Ooh, this is gonna get ugly. Okay, so we're gonna say print bag not in map. Okay, so that's when we get to the bottom. Then we say print bag, so it'll be like shiny gold contained by total outer bags, and then for each outer bag, and then we'll say returning, whoops, print return total. This is like the total number of outer bags. Okay, so let's do a little bit of analyzing here. Shiny gold contained by 2 outer bags. So that much is definitely right. We got that. So we noted before that shiny gold has 2 outer bags, bright white and muted yellow. So now we're expecting to see bright white and muted yellow. Bright white is, because the way the recursion goes, it's not going to be like muted yellow is going to come down there. So we're going to chase the bright white kind of thread. And so bright white, hold on here. Bright white, come on. Bright white is contained by light red and dark orange. Light red and dark orange. But then we would theoretically then chase light red and say light red, which is not a value on the inside. So those light red bags, that's it. So we're double counting. That's what's happening here. So like when you get to the not in map, that's, what is it they want us to find? How many bag colors can you eventually, so we only want to count the outer bags. So the trouble here is that shiny gold is contained by 2 outer bags, which themselves are contained by 2 outer bags. And the 2 are these 2. And so that's why when we get these 2 and these 2, it, I need a bigger example. That's the thing. It's like, do I not, how many levels deep do we not count? Because this is like shiny gold to bright white then has light red, dark orange, and muted yellow also has light red, dark orange? What's up with that? Yep, muted yellow also has bright white and light orange. That's weird. But yeah, I guess it's up. So this is a count of outer bags that can emit. I want to say that the intermediate nodes still count. I think what we're seeing here is that muted yellow and bright white, they're double counting because we're seeing dark orange twice. Is that what's happening? So it's like muted yellow and bright orange, right, like we saw here, and then either dark orange or light red. So each of these are unique things. So we can't, it's not just a straight count because they're duplicates. So we need to add what we find to a set. And so light red and dark orange are not in the map, but dark orange, oh, they're not in the map, but those are outer bags that can hold. So when we get to the bottom, it's not just the bottom that counts though, because bright white and muted yellow also count. So bright white and muted yellow, we encounter those when we say, when I say not in map, right? And then we say contained by two outer bags, bright white contained by two outer bags, muted yellow. So those are inner bags, bright white. So bag, yeah, contained by two outer bags, which are light red and dark orange. And similarly here, shiny gold contained by two outer bags, which are bright white and muted yellow. So when we get inside of this for loop, this color is what we need to add to our unique set. Yep. So this is full set, I don't know, outer set, yeah, outer set. So we're going to pass that along as well. Really should just set a global variable at this point, but oh well. Outer set dot add color. I'm curious what the total is, so we'll keep the total, but I am not counting on that at all. So only in the recursions, when we get to a part where something's not in the map, it doesn't matter because we'll call down and it'll pop back up. And when we're calling down, we've already added it. And so let me just pass in this empty outer set equals set. We're going to move this to here. And we'll return outer set's length. And I blew it because I didn't pass in an outer set. And we get 4, which is something. Well, you know what? Actually, we should let's print out what outer set looks like, just for the sake of sanity. Bright white, yellow. Okay, good. And we're going to now run the real shebang here. So much for worrying about the 1 minute limit, right? 121. Now, what did I say it was before? Oh, 121 was the number. Return 183 outer bags. I think that's what we put before. So 121. Alright. Now the horse be with us. Oh, yes. Okay, I bet this is going to be counts now. It's going to be the worst. Alright, we're getting expensive to fly. But because of the ridiculous number of bags we need to buy. Oh, it's true. 31 minutes. Okay, that's not my best. 31 minutes. Consider the rules from above. Faded contains 0 other bags. Dotted contains 0 other bags. It contained 11 bags. A shiny gold bag must contain 1 dark olive bag. Really? And the 7 bags within it. It does. Faded blue bags. Where is the... I thought shiny gold contained the yellow or whatever from the above example. Yeah, shiny gold, 1 dark... Oh, I see. Right, because it's how many can contain it, but not how many it can contain. So shiny gold contains a dark olive and 2 vibrant plum. We're going to map the other way now? Come on. 1 dark olive bag and 2 vibrant plums. And that's 32 bags. Of course, the actual rules have a small chance of going several levels deeper. Count all the bags. Okay, so now the testing becomes impractical. Shiny gold contains 2 dark red bags. Dark red bags contain... Yeah, we're mapping the other way, folks. So we're going to count the bags without caring about the colors, because this time, before duplicates don't count, this time duplicates do count. As I think is shown maybe somewhere in this example. Yeah, see, no. 2 dark violet bags. Dark violet bags contain no other bags, and when they contain no other bags, that's when we can stop. Ooh, recursion exercises today. Okay. So I'm going to steal once again some stuff. I think our parse 1 still works. We left that flexible enough, thank goodness. Whew. Um, we'll get parse one, we'll print the color rules, I'll grab the rule map, and I'll just take it up to there, and we'll figure it out. I'll remind myself to return something. Maybe cut out some of these prints. Day 2 particle, okay. So here's our things, and so now instead of mapping the counts, well, no, let's make the rule map, but the rule map needs counts. But we don't care about the number. We only care. Okay. So firstly we're mapping outer to inner, right? So that's the big change. For each of these, they contain some number of that, and then we say the inner bags. We're going to do the lookup. So we're looking up by outer bag. So that's the first big thing. Is the rule map now maps outer to inner, all the inner lists, and then we'll go through each inner, look up the outer for each one. And each time we need to get the count. So it might be more practical to do inner comma count for each element. So that's going to change my parsing. Okay, so we're going to move to parse 2. Here is parse 1. I'm going to copy it down to parse 2. Where is parse 2? And previously, what the heck? What happened to this? Anyways, I'll just take that, I guess, or let's this. Yeah, take that. Okay. So this gets the outer, right? So this is the outer, supposedly, if I still remember how to do any of this. First two things. So these are singular, and then the number or the string thinger right before it is the element. Okay, so because we know we want to put into the map is a pair, I have the string right there. So I'm gonna cut this out just for readability. Goodness. Inner name and then inner count is going to be the element split at -4. I guess. -1, 2, 3, 4. And we're going to want that to be an int. Like so. Whoops. And so then we're going to append a inner name, comma, inner count. Just like that. And that should do it for us. Oh, base. Contain. Oh, contain. What the what? So we don't want every single element this time. We already have I been double counting the outers? Oh no, we're only getting the last 4. 1, 2, 3, 4. Why? Huh. I did not expect that. They all have a number, right? Even when there's 1? Like, contain blah? Like, yeah, there's 1. Contain 1. We're dropping bags. That's why we're not going to the end. Let's do if this whole thing is equal to contains, print the element. Oh, contain? Singular? Dark teal bags contain no other bags. Oh. Okay. Didn't see that coming. Okay, so when we have one thing, how do we not have this problem before? Well, at least we have a base case now. So when they contain no other bags, we're done. So what? The color is no other? right? Basically, yeah. Um, so if inner name, so I can get rid of all that. If inner name equals no other, if the color is no other, firstly, we should probably remove the color. Hmm. Then we append an empty list. Yes, 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 yes. Then inner count is 0. Not empty list, just the count is 0. Else we can keep what we had. Right? So now we have, did I do it backwards? Output map. Oh, right, because now we're mapping backwards. So I have to flip the mapping now. Didn't do that part yet. So at least the inner outer will be easy to flip. So the outer now will be, no, the outer is still the first thing we get, and the inner is still everything else. But now for each bag and inner, rule map at outer is rule map at outer. And we're going to map it to a list, so the list is still good. And then we can say outer bag dot append inner bag. Oh, it's not called outer bag, is it? Consistency, folks. That is the name of the game. So now we have light gold maps to lime green, faded green, clear olive, dim bronze. 3 different things. What's nice though is each key is unique in that its outer value. All right, so here's where we first see the breakup. When I break up, I know where I'm gonna be. All right, so actually no, they all line up. And so eventually we'll get to some zeros maybe. Wow, this thing is long. I just noticed the horizontal scroll bar. Crap. All right, here we go, no other. So it's gonna map to the color of no other. That's fine, I guess. Like, just for consistency, like, we want there to be 2 elements, otherwise later it's gonna be a pain, but we gotta remember that there is this case where it's no other. Oh, it should be an empty list. Period. Otherwise, it's going to go looking for no other. That's going to be a mess. So here, whoops, up here, we returned that. Okay, how about in here then? We say we create the thing. If inner, there's no inner bag. Why does it keep talking about inner bags? Oh, it is inner bag. If inner bag, which is this thing, at the first element is no other, we're going to continue and not append to that list this little no other 0 nonsense. And so then it won't add to the count when we do the work, and then dark teal, for example, when we counter it, will, assuming it's somewhere, yeah, so like we're on striped coral, we're like dark teal 1, like okay, we need a dark teal, and so it puts it in, and then we get the dark teal that doesn't have anything, so we stop and we recurse back up. Good, good, good. Okay, so dark teal is our like little albatross, canary type thing, whatever you want to call it. All right, so we're going to do, we'll call this count bags, right? Count bags. And we're going to need the rule map again. We're going to need, oh, it's actually called rule map here. We're going to need, it's going to return the count, and we're going to, oh, right, what are we counting for? Shiny gold is still our bag color, I believe. In this example, a shiny gold bag. Here's another example. Oh, another example. So we'll start with this one, right? It's 32. Let's get that set up here, small. All right, it's still going to take a little work to fix up this bit. Shiny gold rule map. Man, I have to remember all this stuff. All right, let's copy that. And we're going to say that if we have the bag color, so this is outer bag color, and then we want to know how many, I'm going to make this RMAP again, just to save keystrokes. Then this should be easier. For color in, oh wait, first find the RMAP. So every color shows up. It's just that some of them are empty, right? Like we saw that here. Whoops. Eventually, there we go. Some of them, when we look up, it says no other. And then I guess correspondingly says no other down in the key if I can find it. Oh my goodness, what have I done? Okay, so dark teal, there it is. Oh, nope, dark teal actually has a bunch of colors. What? Oh, it's because it's the smaller input. So we should look for the, how about dark violet? No, that's not the actual example. How about dotted black? And we want to go to the bottom of the inputs. Here we go, dotted black. Oh, dotted black apparently contains, oh, that's still the big one. Did I not change it yet? Oh, okay, I haven't changed it yet. Okay. Regardless, when we find it, we're always going to find something, hopefully. So get color, and if we don't find it, let's just say it's blank. And we say this is the list of inside bags, right? Inside bags list, bags plural. And so then we say for color in inside bags, so for each of those, we need to get their counts, right, of those colors. Ooh, I shouldn't say color, for C. And pass on RMAP, and we're going to have a total. And before we call the thing, we're going to, oh, hold on. Each of the things, right, have a number. So it's actually for color count, and so we say color count, and then we say total plus equal to that count, at which point we're then ready to go down into the next level. We'll wrap this for clarity. And we call this, and then what are we returning? We're returning the numbers. But I don't want to return each one. But do I total it again? It doesn't seem right. So each time, so it's not going to return the count of the bags inside of it. Okay, so each time, at the end of the loop, we're going to return total. Like that part is for sure. These two lines are where I'm having contentious thoughts here, because, oh, we can do this, right? Well, no, that won't capture the total. So we get the totals for each one, right? We add it to the total. We say dim orange, we have 1, we have 2, we have 1, etc. But then we also want to call those colors. We go out down into Plaid Plum, and we go and find their counts. So the call to Plaid Plum should return its corresponding totals inside of it. Yeah. And that's fine, because at the total level, we're just getting ourselves. Okay. All right. Run it. 21. I don't think that's right. Oof, 32. Okay. And that's on our little input of shiny gold. This is hot. Shiny gold contains 1. All right, let's print stuff. So we say here, oh, No, it's still. We're not including itself. Because each key, well, we don't know the values yet. So we can say, we get the inside bags. We can say print getting inside bags. No, getting. So we can say outer this. We say print color contains, and we can say like 5, bright white bags, and we should then therefore have incremented total returning total so outer shiny gold. Shiny gold contains 1 dark olive bags, dark olive bags, which contains 7 other bags, 3 faded blue and 4 dotted black. Dark olive contains 3 faded blue, which has none, and 4 dotted black, which have none. Total returning 7. Okay, so that total is good. Okay. Shiny gold contains 2 vibrant plum bags, which, we're not multiplying. When you have 2 vibrant plum bags, no, we are. Are we? Yeah, I think that's the problem. 21 plus 11 is 32. When you have 2 vibrant plum bags and you go down into it, you're going to need to do the count twice. So, do we not count the 2 vibrant plum bags themselves? No, we are, right? 1 dark olive bag plus the 7 bags in it, 2 vibrant plum bags plus 11 again. Okay, so we are counting all the bags. We're really counting all the bags, not just the root nodes. But we want to multiply the count of a given number of bags. Like here we saw there were 2 vibrant plum bags, which contained 5 things of those and 6 things of those. And these are printed in the for loop. So we have each of those counts, and we're going to increment them into the total. So I think we need, increment in the total, and it returns 11, right? So here, this call returned 11 when, on the inner loop there. And so we should multiply this count by the returned, kind of lower value. And that gets us 32. All right, one last gut check. Let's copy this into our small input, and hopefully, put an enter there. Run it. We get 126. It says 126. I'm feeling good about this. If I can find the place to change the input back to normal, that would be great. And we get a number. All right. Yes. Oh my gosh. I don't know what I would have done if it didn't work. I hope this was interesting at least. I also hope that you came up with some better solutions. Let me know either in the comments or whatever where I went wrong. Like, geez, that took a long time. 52 minutes in the books. Whatever they usually say on the YouTubes. Let me know if you enjoyed this. Click that like button, blah, 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 subscribe, yada, yada. And that's 1 week of Adventing in the books. We'll catch you tomorrow, I guess, around the same time, same place. I'm really hoping that we don't have to do more bag-related stuff. That was rough. Every year they have things that will show up again. So I'm just crossing my fingers that that year, that it's not this topic this year. I mean, it can't be, right? It can't just be like more bags all the time. Last year was with like the int code stuff, so it was like you're making a little language, then kept growing on it. I feel like this is a terminal step. So hopefully this is as far as it goes. All right, until then, we'll see you tomorrow.